All right, hi. My name is Robin Dassler, and I'm here to talk to you a little bit today about CERN analysis preservation, which is one of the tools, services that we are working on at CERN. CERN, yay. So first of all, what does CERN do, in case you're not familiar with it? Quick note, I am not a physicist in any way. This is a very overly simplified explanation. So CERN deals in high energy physics, which we also call HEP. Basically, we smush a bunch of particles together with really complex machinery like the Large Hadron Collider basically underground, and we gather data on the smashings and what pops out of it, and we use that to make conclusions about life, universe, and everything, and all that kind of stuff. But what you basically need to know in terms of what we're doing here is that CERN is also a central place for HEP, for high energy physics, because we have all the equipment. So basically, anyone involved in that field basically either comes through there at some point in their careers or uses our data, the data produced by CERN. So quick explanation, kind of, on very crudely, of the experiments that are on the LHC, big ring. So there's different instruments at each of the collision points, and they record data. They go by different, funny acronyms. We refer to them as experiments. But when we say experiments, we really mean enormous collaborations of a lot of people doing very complex things. So each experiment gathers huge amounts of data on collisions that are happening many times a second. So all the different types of data that come out of the LHC, we have our little pyramid here. Basically, it starts at the bottom of the pyramid, where all of the basic kind of raw data is coming off the instruments. This is huge amounts of data. This is data that isn't really very readily humanly possible without some kind of analysis. Then it goes through kind of various layers from reconstruction all the way up to what you might ultimately see in a paper that's represented by a little tiny table. So it goes from giant piles, it gets kind of progressively analyzed and munged down into more and more digestible pieces until we wind up with sort of publishable bits at the end. So we have different types of data at different points along the pipeline and different points along the pyramid that we need to address. And the one that we're talking about today is this sort of middle layer of the reconstructed data, all the information that goes into a physics analysis that we then need to somehow preserve. So yeah, we're preserving an analysis. And so what goes into an analysis? A lot of different stuff. Basically, this is an amalgamation of all the different kinds of raw files, the software used for processing, any other kind of documentation on what went on during the analysis, as well as papers, conference reports associated with the analysis, and as well as some internal notes and some internal review processes. So what we really wanted to do throughout this development is come up with a way to kind of preserve all these different disparate elements and gather metadata about them and preserve them kind of all in one place, and to also facilitate our internal review processes. So I should say that what we're trying to do here is construct an internal tool for sharing. This is not for sharing data publicly. We have other systems for that, like CERN Open Data, and like HEP data, as we'll see in other presentations. But this is really an internal tool for kind of sharing the combined knowledge around what went into an analysis with everybody else who might need it. Because whether you're an experimental physicist or a theoretical physicist, there's a lot of different people and a lot of different stuff involved in this, and you don't necessarily, even if you need to use the data, you were maybe not necessarily involved in its creation, and so you don't really necessarily know how it all goes together without some preservation there. So to this end, we are developing CERN analysis preservation. This is what the tool is called, because it's preserving analyses. Here's a quick demo screenshot. This is currently under active development. What we really want to do with CERN analysis preservation is make sure that it is including all of the different sort of systems we might already want to use. So Twiki, GitHub for different codes, there's various internal databases that come from the different collaborations, that come from the different experiments, and all this sort of thing. And so what we do here is we are building the knowledge base by gathering information from the people that are actually doing the analyses. So we're trying to sort of gather it as they're going along. So we have all different kinds of forms for this, of course. Basic information, different information about the inputs, a lot of different sort of embedded nested information about all the different kinds of measurements that might go into this. And a lot of this has taken a lot of effort with really talking with the physicists and trying to determine the language that they need for all of this and kind of how they can best describe this information. Again, as well as the internal discussions, publications, and all that other kind of stuff that goes with it. All this underneath is represented with a JSON schema. So this is also a lot of work we've been doing to kind of develop this behind the scenes, to figure out how to describe all this stuff and to describe it in a way that's easily processable. So that's sort of a quick rundown of all of this. Where to find us? Well, you can visit analysisfederation.cern.ch. You can't really do a whole lot with it because you guys aren't internal to CERN, but you can at least sort of see what it looks like. And the code and some more documentation about our various use cases is up on GitHub at the project repository. And then the collaboration between both CERN IT and the CERN Scientific Information Service, which is kind of the tech part of the library. It says the multiple person group that goes into all of this. And that's it. That's me. That's a good rundown.